Okay, put your window back in there. Okay, domain name services. Everything we've looked at so far is using numbers, either a MAC address, whole bunch of hexadecimal digits, but still binary digits, or IP addresses. IP addresses are also used for addressing. As you work further into the OSI model, you're going to see that the addressing, IP addressing, and MAC addressing are both used within the frame, and see where those are all put. But the point is that you do need IP addresses. You need the numbers for you to actually send those frames or to send that data from computer to computer. We don't do it very often, though. We end up trying to remember things by their name. If I want to get to CNN's website, I don't look up or use a number. I type in CNN.com. How does that get translated to a number then? That gets translated to a number through the domain name services. It's a method to use to correlate IP addresses with more human-friendly designations. Special computers do this. They're called domain name servers, and they keep databases of all this. So if I look up totalsem.com in an internet browser, the DNS server at some point or another shows that. Here's kind of a picture of that. Does anyone know the IP address of totalsem.com? Here's the example of it. It's 209.34.45.163. That goes back to here. This number gets put inside that frame, and now the web client is able to connect to the web server directly because it has its number now. We can see some of this. The internet has regulated names and domain name qualifiers. They're called the top-level domains. Such things as .com and .edu. The new TLDs are added occasionally to keep up with the changing internet. You probably have heard of some recently in the news, but try and keep up with that. The Internet Corporation for Assigned Names and Numbers, named ICANN, they regulate those top-level domains. Here's a couple of examples. .com for general business, .edu for education, .mil for military, INT for international, .org, .gov, .net. They have been pretty strict in the past as far as .org, you have to be a nonprofit organization. Some of those qualifications or requirements needed to qualify for those domains have been relaxed a little bit, so you have a little bit more flexibility of who can have a .org or even a .net. It used to be just internet service providers. Even .com, you don't have to be a business. You could be a family and have a .com. Some of the ones that are regulated and controlled very strictly are .edu, .mil, and .gov. Those you can't do unless you can prove that you are an actual school or a military organization or the government itself. Taking a look at the name servers, you can actually run seeing what an IP address would be for a domain. We're going to go to a command prompt. And the command would be called nslookup for name server lookup. So like my example of www.cnn.com, it's going to tell me that CNN's website is in fact 157.166.255.18. So you can find out that information as well. If you want to find out what eBay, every time you go to eBay, what address are you actually going to? nslookup, ebay.com, and both of these cases, they actually have a couple servers, so it could hit any one of these, but 66.135.200.161, that's the number that gets put inside the frame then. Okay, entering IP addresses. To configure a computer to connect to a network, you must enter the IP address and the subnet mask. And again, these always go hand in hand. They can never be separated because you won't be able to tell what's what without it. The default gateway, which is how do I get off of my network and out to the rest of the world, and where's my phone book for looking up those numbers. So those are the pieces of information that you would enter in your computer. We're going to talk a little bit later on of how that happens automatically using DHCP, but looking at that information right now. In Windows 7, we can see it underneath Internet Protocol version 4, properties, use this following information. Here's the IP address and subnet mask, again hand in hand, the default gateway, how I get off my network, and where do I look to get my addresses. I'll actually walk you through this. To get to there, one of the easier ways of getting to it is if you have a network connection down in your system tray or your notification area. If you right-click on here, my network connection, sorry, a little network connection down here, Open Network and Sharing Center. You can also do that through the control panel. You're going to find Network and Sharing Center there as well. I'm just kind of get used to having it down the corner. Either way, we manage the adapter settings. So this is dealing with the physical adapter, whether it's wireless or wired. So I'm working with the adapter. Now you can choose the adapter you want to work with. I'm going to use my local area connection. Actually, let me use my wired one. It says LTC wireless. No, this is my wired connection. The little picture of the wired sort of gives it a hint. If I look at my wired connection right now, I can right-click on here and then go to Properties. So again, let me back up a bit. Network and Connections, Network and Sharing Center. Manage, change the adapter settings, Find the adapter you want to work with, and go to Properties. Right-click and go to Properties. When I go to Properties, you see all the different protocols and items down here in the bottom. We are working specifically with IP version 4, TCP IP version 4. So we want to click on this, and we click on Properties. Right now it says obtain the addresses automatically, and that's what it's doing. We'll take a look at what our addresses are right now, but right now it's doing it automatically. If we want to assign them, then we click on use the following IP address, and then we have to enter all this stuff in. So we have to enter the IP address and subnet mask. That's all we really need to enter if we're just talking to other computers on our same network. If we want to get off of our network, though, then we have to use a default gateway to tell us, hey, how do I exit here? If you're good at knowing the IP address of every server you want to connect to, you don't need a DNS server. If you would prefer to use CNN.com as opposed to that IP address every time, then you would want or need to have a DNS server here. I'm going to hit cancel here so I don't actually configure this. But we can see what our current address is right now by using a command, another command line command called ipconfig. ipconfig. A lot of my adapters are disconnected. Let me go ahead and find my adapter that is connected. Ethernet adapter local area network. Here's my IP address, 172.16.193.2. My subnet mask is 255.255.240.0. And my default gateway, this is the computer or the device it has to go through to get out to the internet, or any place else is listed there as well. If I want more information, I use an ipconfig/all. And that shows me the same information as before, but now it includes additional information as well. So here's my Ethernet adapter local area connection. This is the same information it gave me before of my IP address right here, 172.16.183.2, my subnet mask. Here it also gives me my IP version 6 address, and here's my physical address, which is my MAC address. My domain name servers weren't listed before. They're listed down here. So every time that I go to eBay or CNN or BestBuy.com or Walmart or wherever I'm going, or CNET News, it is going to 172.16.16.140 to resolve that name. The DNS is actually a tiered approach. So you will, if this server doesn't know what it is, it'll go up to the next level, up to the next level, up to the next level. There's a top level, it's called a tier 1, and then start to go down to tier 2 and tier 3 to resolve those names if need be. So that's where you can find that information. Going back here, DHCP provides your computer with all the IP information that it needs. None of that information that I just showed you on my screen I entered or anybody entered. It just happened automatically because this server is set up to provide all the information. So IP address configuration is unnecessary in this circumstance. There's times in certain networks, though, that you do want to have statically assigned addresses. That's the case with usually network devices themselves, switches and printers and servers, and maybe administrative consoles. Here's a picture of how this works. I'm new on the computer. I don't have an IP address. Can you give me one? And it says, sure, let me give you this one. It knows what's been given out because that's the device that hands them out, so it's not going to have duplicate IP addresses. And it says, go ahead and use this. The next computer comes on and says, okay, I'll give you the next available one, 192.168.11, possibly 43 and 44. Okay, the last major section is network organization. How do we get these things to talk together and sort of work together logically and even, making it happen? Workgroups. Workgroups are the most basic and simplistic of the three network organization methods. It's default for almost every fresh installation of Windows. And in fact, it'll even default to workgroup in most cases. Sometimes for some computers, it depends how they're set up or which version of Windows, they might default to home or to home, well, a couple different things that could be done. But you can change that. It's definitely customizable. Every computer in the network needs the same workgroup name to be able to share resources. Therefore, just using the default workgroup makes it nice because every computer that you install is probably going to have that. If you want to have different workgroups, you could have one for sales, one for accounting, and that just keeps the traffic sort of separate and keeping it less congested that way. If you go to your computer, start, right-click on Computer and Properties, on the bottom of that page, it's going to tell you which workgroup you belong to if you belong to one. So this defaults to workgroup, and you can, which is the default that it shows. Changing the workgroup. If I want to change the workgroup, I can right-click on my computer and click on Properties. And this is where I can change the settings for the computer name, whether I want to join a domain, which is actually the next topic, and the workgroup settings. A lot of people, if they want to change the workgroup or change the computer name even, they'll be starting typing up here. That does nothing. This is just the computer description. For example, the kitchen computer or Mary's computer. In order to change the computer's name or its workgroup, you change it down here. If you want to join a domain or a workgroup, you click here. If you want to rename the computer or change its workgroup, you click down here and change is where we would go. We could change this then to, if we want to have it by classroom, we can make this our own, very own workgroup, L119. We can make one called LTC so that the general computers don't see it, but it's only for those computers that are set to LTC. If you want to change your computer name ever, you'd be changing it up here. Most of the time this requires a reboot, so when you do change the workgroup or your computer name, your computer will need to reboot in order to take effect of those changes. Workgroups lack centralized control. Everybody's on their own. I say that I want to share stuff. You say it's okay. I can share your things. You can share mine. As long as we're in the same work group, we're able to communicate and then share. But there's no central way of dealing with that. Each username and password are stored on the individual computers. So if I have computer 1 with user 1 on it, and then I have computer 2 with user 2 on it, if I want to access user 2, the computer 2 stuff, I actually have to log in as a user on that computer. So every time you do that, you're logging in multiple times, and it can be a little cumbersome, a little tricky of knowing even how to log on to the other computer. Shared folders and files grant access based on local computers' policies only, which means that, go back. Let's see, only in a work group. So if I have a local computer, you'd have to log in as that user onto my computer to be able to access that share. Unlike when we work with domains in the next group. And here's just a typical Windows 7 login screen. If I want to share, all I do is find the folder I'm working with, right-click, and click on Share With, and then who do I want to share it with? And I can choose. I have three options to share within a work group, or three ways of really doing it. The one way I really described so far is pretty common. You make the people log in onto the other computer using an account on that computer. So if I want to access computer 2, I log in as a user that is created on user 2. You can create the same accounts, which has the same username and same passwords, on all the computers and give sharing permissions to all the users for all the shares. A little bit trickier that way. So if you have computer 1 and computer 2, you'd have to create a user 1 account and a user 2 account on both of those computers and make sure they have the same password along the way. It does make it convenient though, so when person on user 1 from computer 1 wants to use something on computer 2, they're already kind of created, all the usernames and sort of match. 2 users on 2 computers, not a problem. 10 computers and 10 users, now you're having 100 accounts that you're actually managing, and then making sure they're all synchronized and stay all the same. You can use one account on all the computers. Everyone logs onto the same account, and then all shares are by default assigned to the same account. So you don't have to worry about all those different users having different accounts on all those computers. You just have one account. You just put that on all the computers. So instead of user 1, user 2, you just have user, and they all log in as user. Not the best ways of dealing with things that way, but it is quick and convenient. Here's an example of a computer logging in, computers A and B, computer A Mike, computer B Fred. I want to access something on the other computer. It's going to ask you to log on to that computer. And again, knowing how to log on to the computer would be really important. Domains. Larger networks that need more control use domains. This is the true client-server environment. Those pictures way at the beginning of the slides or the PowerPoints showed a Windows Server 2008 server and then 3 or 4 Windows 7 computers. They are part of that domain. Domains offer huge advantages and tremendous central administration. We talked about user 1, user 2, user 3. You no longer create those on any of those computers. They have no local users. You only create those users on the central domain. The domain then, the computers then connect themselves to the domain, and showing you that on this screen of how to join that domain. I right-click on the computer, go to Properties, and I want to change. If you want to join a domain, I click the network ID, and now it tells me that I want to join a domain, and you point to that computer where that domain is held. Once you've done that, you're really locked to that computer. They will have complete control of your computer and your user accounts and everything. Definitely advantages, but realizing that you're giving up that individual control. To make it possible to track each user, each resource, and what each user can do at each resource. So it's very, very powerful in controlling that. Where the domain runs requires a server. The current versions include Windows Server 2008, Server 2008 R2, and then Server 2003 can also implement domains. The systems running the Windows Server products are called the domain controllers, and that's where the user accounts are. That's where the database that keeps track of all that's really is actually functioning. Computers and network must join the domain to access the domain resources. And I just showed that screen as well. When logging into the domain, Windows prompts for a username instead of showing all the domain users on the network. That would be a really long list. So you actually get the login screen when you're connected into the domain instead of all the local users showing up across the screen. It'd be impossible to show all the domain users on the screen and having to click on yours somewhere. I'm in control now. You all log into me. That's true. That's the only option you really have. And if I want to stop you from doing something, I can. If whatever control, this controls everything. Great, great, great for network administrators. A brand new feature in Windows 7 is called Home Groups. It uses the idea that people want to connect data and not just folders. When we're looking at even work groups, we went to a folder and said, hey, I want to share this folder. Home groups work a little bit different. Home groups skip folders and share your Windows 7 libraries by default. If you remember from last week, going into the Windows 7 libraries, there are sort of collections of folders. So I'm looking at pictures. I want to share pictures. I don't want to share this picture folder and this picture folder and this picture folder. I want to share pictures in general. When you're working with home groups, here's a screen for it. The default home group dialog box. There is currently no home group on the network. Well, let's create one. And it takes you through the process of creating one. You can only really have one home group on a network at a time. So once you create a home group, the next computer, when it comes into the home group section, says, there's a home group, you need to join it. During the creation, if you want to do anything with home groups, you need to join that home group. When you create a home group, it's pretty simple. It just pretty much comes up with a password, and it's automatically generated and kind of cryptic. That is what you'll need to use to have any other computer join that home group. Once the home group is joined, then you decide what you want to share with it. The 5 defaults are pictures, music, videos, documents, and printers, but those things can be taken off and additionals can be added. All data is encrypted between the systems, so if somebody is sniffing on the network, they're not going to be able to see the traffic that actually goes across there. Like I said, all home group devices connect using a common password. There's no username required. You're not logging onto that computer with that username and password. And each computer can be a member of only one home group at a time. And here's that picture of the screen showing I want to share my pictures, music, videos, and printers, but I don't want to share my documents. Here's that password that's created when you create the home group. It's going to be randomly created. You'd have to write this down. It actually says print this in the little underneath here, so you can print it and take it to the next computer if you're going to, add other computers to the home group. You have to type it in exactly that way. Here's the home group configured, again, showing what shares you want to be using. And it says this user created a home group on the network. And again, sharing additional libraries or even folders is done by right-clicking on an item after a home group is set up. So you can go back and share a folder. So now that a home group is set up, I can right-click and share. Or you can create additional libraries and share those with the home group as well. How you share them is nobody. This item is not shared. Or you can share it with the home group as read writes or read write. Read lets you view the stuff but not delete it or change it in any way. Read write lets you modify it or update it or create new objects. Or you can choose specific people, but that gets really into the old traditional way of sharing. Using home groups, underneath home groups, you now get to see the actual home group. And let's see, the share with a menu. Who do I want to share it with? I want to share it with nobody. I want to share it with everybody in the home group as read, or share everybody in the home group as read and write, or I can choose specific people that I want to do. And that is it for the PowerPoint. Do you have any questions? Not really? Okay. Okay. Okay, going over the key term quiz and the multiple choice quiz. The version of Ethernet that runs at 100 megabits per second is known as 100 base T. Number two, the Ethernet cables typically use what type of connector? It's the RJ45. Most common Ethernet topology is the star bus. And that's because it's the star physical layout, but the bus logical. So working inside, it's going to run like a bus, but it's looking like a star on the outside. That tells the computer that which part of the IP address is a network ID. That's the subnet mask. The book talks about all the 255s are where it's the network ID part of it. That's true. It's not just 255s though. For example, if I have a subnet mask, I'll maybe type it up. Notepad. So if I have a subnet mask of 255.255.0.0, that would actually indicate these are all ones. If I convert this to binary, 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8. Wherever I have, let me make it bigger. Wherever I have ones, a 1 equals a network ID, and a 0 equals a host ID. So in this case, I'm using 16 of these 32 to represent the network. So this portion would be the network. It's not just limited to 255s, though. If I have the number of 128, how do you convert that to binary? What's binary for 128? This one would be changed. This would be a 1. So you can see that the dividing line now would be, these would be the network IDs, and so forth. If I went even further, if I went to 192, 255, 255, 192. If I converted 192 to binary, I would have 11000000. And hopefully you get this in math and logic, or if you don't, come to class next week and ask, because I love converting from binary to decimal and back and forth, so we can go over that process of how to convert. But let's just say this is just the converting process. So I could go the other way, though, too. I could just have these bits. Well, then I have to represent my subnet mask. That'd be 254.0.0. And again, that just tells me that I'm using 7 of those bits to be network ID. So the network ID would be in here. Which network do you live on? It'll be represented in here. The rest of these numbers in your IP address would be your host numbers. And again, the subnet mask only helps you interpret the IP address. So the subnet mask interprets the IP address. So if I have the IP address of 172.16.132.6, I'd have to convert this all to binary, and I'd find out which of those bits are which. So again, dot decimal notation doesn't do as much good in here because I need to convert 172 to a binary number to find out which of those bits are going to be network bits. Okay. Number 5. Most Ethernet networks have a central control box called a switch. And number 6, all NICs have a unique identifier called a MAC address, or immediate access control address. Sometimes it's called a serial number, even though that's technically not correct, but I've seen it labeled that way. Other times it's called a hardware address, but they are unique. Routers enable multiple LANs to connect. Once they're connected, they are defined as a wide area network. This is a much better definition than the slide has as far as a wide range or long distance. Number 8, Windows 7 enables sharing of libraries using Home Group. Home Group is the only option to share libraries. You can share folders with work groups, and within domains, you don't share anything. A Windows domain enables single sign-on, so I can access all kinds of resources all over the network with just a single sign-on. Once that domain, and then that domain gives me access to all the computers that I should have access to. The numbers 192.168.5.36 are an example of an IP address. Okay, moving on to the multiple choice quiz. A MAC address has 48 bits. An IP address has 32, so 48 bits C. Which protocol enables the use of names, such as totalstem.com, rather than having to type in the IP address? That would be DNS. DNS, the domain name server. I type in the name, you give me back the IP address, I use that IP address then to communicate with that device. What's the minimum category level for 100 base T networks? And that's category 5. Which operating system enables you to implement home groups? That started in Windows 7, so C, Windows 7. Windows Vista did not have that. Which of the following is an example of a hybrid topology? And it's Ethernet, which is our star bus. So it's going to look one way and technically act a different way. A star bus topology. Which of the following is an advantage of a domain-based network over a workgroup-based network? And of those listed, single sign-on is probably the best answer. I'd probably argue also with ease of administration. It'd be a lot easier to administer having one location instead of multiple locations. It would be more difficult to set up, so that aspect of administration would be more difficult. So probably the best answer is your single sign-on. A typical Category 6 cable uses which type of connector? That's an RJ45. And in fact, RJ45s are used for Category 5 on up. Actually, Category 3 on up. Number 8, why would you use STP over UTP? Why would you use shielding over unshielded? Well, cheaper? No, it's going to be more expensive. The unshielded is going to be less expensive. Easier to install? They're identical. They're going to look and act the same. In fact, shielded will be a little bit more difficult. It's a little bit stiffer, and you need different connectors. Better to avoid interference? Absolutely. That would be the only advantage. They are not cheaper. And they're interchangeable terms? No, they are not. Number 9, what kind of frame gets received by all NICs in a LAN? That'd be a broadcast frame. So it's going to be going to all the computers on that domain, broadcast domain. Number 10, Internet Explorer, Mozilla Firefox, and Google Chrome are all examples of, it's a web browser. The browsers, web browsers allow you to access a web server. 11, which of the following does 255.255.255.0 most probably represent? It most probably represents a subnet mask, because you have a whole series of ones and then a whole series of zeros. It is possible to have this as an IP address. Unlikely, but very, very possible. It's completely legitimate. There's no reason that you can't have it. But it certainly looks like a subnet mask. Which of the following is the default network organization for a new Windows installation? Basically, if you have a work group, what's it going to be called? Work group. What is a remote computer providing resources called? It's simply called a server. And servers provide services. So I can connect to a file server expecting file services. I can connect to a web server expecting to be provided with web services. The total amount of data that a network can handle, that's known as its bandwidth. And that's with the measurements of 10 megabits per second, 100 megabits per second, or 100 megabits or 1,000 megabits per second. These discrete chunks of data that the network transmits and works with, They're called frames. Working with the OSI model, they actually go on up. Frames are consisted, there's actually packets inside frames. Inside packets are segments. So we talk about chunking of the data, but the network works on it at the frame level. So the answer is A. Questions on anything? Take a look at, let's see. Okay, the question is, can category 3 handle 100 megabits? And do you have a chart? I don't have a page open right. 133. Yeah, that would be a tricky question. That would be a tricky question because the way that that note is put on there, technically category 3 does handle it. So what review question was that? Oh, it wasn't one of the choices. Okay, I thought it was a question as far as, oh, I see. Question number 3, what's the minimum cat level required for 100 base T? So of those selected, it's definitely B. But yes, category 3 can support that. It's a special version of it or variant of it, but it is still technically under category 3. So yes, category 3 would be the correct answer for that. Yeah, variant. The category 5 is the best answer, but I like the little note on the side of page 133. It does say that. Although these days you'll only find Cat 3 installed for telephones and very old networks. CompTIA traditionally enjoys tripping up techs who don't know it could handle 100 megabits per second. So I guess if you're taking the exam, that'd be a good thing to take a look at. Excellent catch on that. Other questions? Nope. Okay. Like I said, the rest of the learning plan is out there. Let me see if I can find it for you real quick. At least it should be out there. Learning Plan 6, the visible networks, the assessment activities. This is completely on your own, anywhere between 12:05 a.m. Tuesday to 11:55 p.m. Wednesday. You take the Chapter 4 quiz, the visible windows. If anybody has any questions or problems accessing this, definitely let me know. It is 32 questions, a little bit longer than normal, quite a bit longer than normal. And I believe I have it set to give you 45 minutes. But again, you've typically been getting 20 question quizzes done in 3 or 4 minutes, so that shouldn't be a problem. We talked about the basic functions of the network, discussed the difference between LANs and WANs, which is really important, and then where TCP/IP fits in, and then our resource sharing, work groups, domains, and home groups. Participate in the class discussions as we did in class right now. Here's the PowerPoint for it. And then right now we're doing the videos and recording it, so we'll have the links for the videos there. And then your hands-on sheets, activity sheet. Your hands-on activity sheet, you're not having any of the lab exercises. Oh, hang on one second here. Let me look at this. I said that before, but we're going to. We'll be able to get those done. Let me think about this. 1 second. Kind of went back and forth on that. Oh, I miswrote these. I will correct these, and these will be updated hopefully before you get to them. It is not lab exercises 6.1, 6.3, 6.5. These are the lab sim exercises. So I will correct that. It's going to be the lab simulator. There will not be anything of the lab manual this week. The lab projects are in the textbook, Project 5.1 and 5.2. So we're going through that. Some of the things are covered in the class. Any questions, please ask me. And then we're doing lab sims 6.1, 6.3, 6.5, 6.6, and 6.11. So glad I saw that. I will get that corrected right away. Down the bottom, same routine. Get ready for next week for Chapter 6. Read Chapter 6 and complete the key term quiz, and then also the multiple choice quiz. Adding it all together, it is worth 45 points. And there will be a quiz on networks next week. So I will correct this as fast as I can. Questions on this? Does that make sense? Okay. Okay, that's all that I have, so the rest of the day is yours.